Again, my name is James Reggio. I'm the tech lead on the web platform team at Convoy. I really appreciate the Apollo team inviting me to speak here today. They've been a great partner to us. Convoy was a company that was founded right around the time that GraphQL was announced on the scene. So we've actually been able to embrace GraphQL from the start, specifically Apollo, and grow with them. As you can also probably see from the title of my talk, I'm going to be taking us back to the front end. I saw earlier from a show of hands that maybe 20% of the people here have worked with hooks, but would you give me another show of hands if you've ever worked with Apollo and React on the front end? Great, okay. So that looks more like 50% of y'all have worked in the front end. What I'm going to be doing with this talk is I'm going to try to tell a story using some practical examples of code that I pulled from our apps about the way that we evolve the way that we write GraphQL for the client at Convoy. There's been sort of three distinct patterns that we've embraced, and they've always been sort of the best practices at the time. But the transition from each has to sort of be motivated in order to justify the refactoring work involved. So I'm going to explain with some code samples how we made those decisions and what benefits we witnessed. Before I get into that, let me just tell you a word or two about Convoy. Convoy is a Seattle area tech startup founded 4 years ago. We are basically out to revolutionize the trucking industry in the United States. And the best way to think about what we do is that we provide a marketplace for truckers and carriers, for shippers and carriers to connect. So on one side of that marketplace, we have hundreds of enterprise businesses. They tend to be pretty large, like Niagara or Unilever or Anheuser-Busch. And then on the other side of the marketplace, we have tens of thousands of small business owners who actually own the trucks and move the cargo. We build the marketplace, and we focus particularly on reducing waste in the trucking industry. Most people are pretty familiar with the fact that like every single packaged good that we consume here in the United States gets to them via truck, and that trucking is really important to the US economy. But the thing that a lot of people don't know is how wasteful it is. According to recent estimates, almost 40% of trucks on the road are running empty with no cargo in the back. And that waste is terrible for the environment, and it's also terrible for our economy because it drives up the cost of consumer goods, and it means that people aren't making as much money as they could be. So we're focused on reducing that level of waste. To speak more about the technology at Convoy, we actually just this week surpassed the 100 engineer mark. And as I said earlier, we started the company about 4 years ago, and we, at that time, decided to embrace the JavaScript and TypeScript ecosystem. So our entire stack is some amount of JavaScript or TypeScript, and we've been converting more and more towards TypeScript over time. Let's see, so we have about a half dozen apps out in the wild. They're a mixture of React and React Native, and we also have roughly 20 to 25 services in our service-oriented backend. So we're growing fairly quickly. There were 30 engineers just a year ago, so you can imagine that we need to think about how we scale our practices. And I said a moment ago that we were early adopters of GraphQL. What was great about the timing was that we basically chose to embrace Apollo right when it was released, and we chose it because it had both a client and a server offering. We chose it because it offered more flexibility than what Facebook had to offer with Relay. And we chose it because the team behind Apollo was incredibly transparent about the roadmap, the shortcomings, and what they intended to do with the product. We have no regrets about it. But as most people know, JavaScript moves really quickly, and I would contend that client JavaScript moves even faster than the rest of the ecosystem in general. So every 3 months, it felt like there was something new showing up, some new shiny way to write client JavaScript to connect the GraphQL database or the GraphQL API to our front end. Over the past 3 years, we've seen a huge number of Apollo client features released. We've seen major evolution in tooling, which we heard about earlier today. We've also had like evolution in sort of industry best practices. And just last November, the React team kind of turned the whole world on its head and introduced React hooks. So we're a business. Even though we're still fairly small, like any large company, we need to be able to justify the changes that we make to our development model. And so on the web platform team, we tend to think a lot about whether the features that have been released to the market that we could consider adopting are going to increase the robustness or the ergonomics of the development experience. We want to see like a major step change function in both before we choose to adopt. And just to clarify what I mean by that, with robustness, I'm speaking of like general correctness and the facilities in the code to make sure that you're not writing and introducing bugs. And then ergonomics speaks to just, is it fun to write code in this environment? So we do pay attention to both of those. What I'm going to do is we're going to hop over to Code Editor, and we're going to take a look at 3 distinct phases of a component as we sort of began, as we would have written it back in 2016, and then sort of as we began to move into some of the technologies that were available last year, and then finally what it would look like today in our code base as we begin to embrace hooks. My hope with this is not necessarily to explain how all of the older technologies work. If you've encountered them, then you'll probably, some of the pain points may resonate with you. But much of the older technologies were deprecated because they're difficult to understand and explain. So I'm not going to spend too much time on that. Instead, what I'm hoping you'll gain from this is you know, maybe you'll see where your company is, or you'll see like the code base that you're working in represented in here. And what you'll see is some of the benefits that may occur should you migrate forward, because we always want to be justifying it with very specific value propositions. So I'm going to move over to my editor now. Hopefully I'll have a better luck presenting with these color scheme. How does that look? Can everybody read that? All right, thank you. So let's wind the clock back to 2016. In 2016, just as Danielle said, there was like a huge, there was massive adoption of Redux for managing client state, and React was popular, it was solid at that point, and everybody was basically refactoring their code base to use this concept called higher order components. Higher order components are this nice encapsulation technique that maps to how React handles APIs at the component level. And the idea was basically that you'd separate a concern out of your components. Maybe it would be local state management or global state management or API data fetching. And you put it in another component that injects that data into your component. It's this nice approach to encapsulation, but it had a lot of rough edges. So what I'm going to do is I'm going to walk you through sort of a mock component that you could have seen in one of our apps, and we're going to see how this component evolved first with using hawks onward to other iterations. So if we look at the left pane, we're going to see this shipment details page, and there's a lot of things in here that actually look exactly like they did in Danielle's talk. You'll see that we're having some props passed in that contain the results of a query. Down here, we're also grabbing some functions out of the props that we're going to pass onward, and these functions actually map to mutations. We have that common boilerplate in the middle, which is like common to every single iteration of this component, which is that we have to handle all these sort of edge cases around errors, loading states, and maybe some business logic errors around like a shipment not being found. And then ultimately, we go and we render some other child components. In this case, we have a shipper summary, a carrier summary, and a little stops editor that would allow us to visualize and add and remove stops to the shipment. This is fairly standard React. It's, I will say that like this was a major step forward, not having to worry about data logic and any kind of fetching logic in this component was a huge step forward from the past, where you'd usually use some kind of lifecycle method like component did mount to make a fetch to some REST API and then parse it and store it in the state. Like, we're not doing that anymore, and that encapsulation was a major win. Let me show you now, though, how the fetching does occur. As I scroll down here, we're going to see a bunch of the higher order components. Each higher order component here is represented with a call to this GraphQL method. This was basically the only way to bind to a GraphQL API when Apollo Client was launched back in 2016. And it was modeled after what Redux was doing with the connect higher order component. You'll see that we have one in here that defines a query. And then we have these two others that are injecting some mutations into our component. It seems pretty reasonable at first glance, but there are some really pointy bits about this that would oftentimes lead to a good half an hour to half a day of debugging to try to figure out what went wrong. The first thing about it is that these higher order components don't naturally layer onto one another. They all define props, and they pass through the props that they receive and then add some more. But if you have multiple mutation higher order components, for instance, you might actually find that one of them is going to override the other unless you give it a unique name. This is something that actually led to, I've lost plenty of time to trying to debug this, especially when the higher order components themselves are defined in another file. It's very easy to layer on a couple and then realize that you're not getting all the information you expect. Another problem with them is that it's really, really difficult to type them. When we began, we did consider using TypeScript, but there wasn't much value to it because it was so difficult to express typings for higher order components. Even the tools that will do code gen nowadays don't really give 100% accurate types. So you don't have any ability to statically verify, say, that you're getting all the props that you expect, or that, that you're not doing something illegal or error prone. One of the other things that is unfortunate about this, kind of in the meh category, but not necessarily a showstopper, is that when we want to specify values for the variables to these queries and mutations, we reach into the props, but we do it here, way down on the page, like outside of the component itself. You typically think about props right alongside the component, and when you think about refactoring props, you'll usually do it right here in the component, but it's really easy then to forget that, hey, I need to come down here and change the usage of the props. Again, this is exacerbated when you factor these out to other files. So that's less than ideal. There's one other thing that is unfortunate about higher order components, which is that if you launch up the React debugger, you're going to see that each one of them actually inserts a component into the visual hierarchy. And so when you look at your debugger in a GraphQL app, oftentimes you'll see more higher order components than you'll see visual components. And that's just more or less a nuisance. There's nothing really painful about that, except for when you start using this in React Native. We have a React Native app, and obviously React Native runs on mobile phones. But one of the things about running React Native is that you actually are using let's say, there's kind of it's a kneecapped form of the JavaScript runtime. It's not able to JIT compile your code, so there's a whole class of performance benefits that you're not able to enjoy when you're running React Native code. And we actually did see that this increased component hierarchy depth would lead to performance degradation in our app. So it was something that was actually a little problematic, and we spent time trying to reduce the number of queries we use and make more complex mutations and things to work around that, which isn't really how you want to think about it, because then we start breaking the encapsulation. There's one positive thing I forgot to cover right up front, so I'm going to backtrack for a second and speak to that before we move on and see how we can actually improve upon the bad and the meh. And that is that we embrace this concept called component local fragments, which is something that we borrowed from Relay. Relay is Facebook's GraphQL client API, and like I said earlier, we decided not to embrace it because it wasn't part of a broader ecosystem, and it was too inflexible for the use cases that we envisioned. But one of the things that it did well was that it encouraged you to break up your queries and put little fragments of your queries alongside the components that use that data. So what that looks like in practice here is if I go into the carrier summary component, we'll see what I mean. The carrier summary component has a very uninteresting render method. It just takes the carrier and it renders the name and the rating. But what I want to show you here is that we're also attaching this GraphQL fragment to the carrier summary component that specifies precisely what fields we're expecting on the carrier type. The fragment is like the most basic form of reusability within GraphQL, and the idea of co-locating it with the UI that depends on that data is something that is very powerful because it gives developers confidence that they're going to get the data that they ask for, and when they're refactoring, it makes them confident that they can remove a field. The latter is really important because I'll say that I've worked in code bases where all the fragments, queries, and mutations are basically in one central file. You might have something like a shipment summary and then full shipment fragment or something along those lines. Those things tend to become append only, and over time, you end up with something that approximates a REST API because developers tend to feel very uncomfortable removing something a field that might have an impact on some other bit of the UI. So we did embrace this approach to co-locating the data dependencies alongside where they're used. And the only downside to that is that they're a little bit error prone. This speaks to the selection sets being error prone. We have a little bit of a problem where if we were to remove rating right here, there's nothing that would prevent us from using it in the response. And that's where TypeScript is going to come in and really save us. So this is what things look like. This was the state of the art in 2016. I would say that we were on all the best practices at the time, and that we definitely were able to find great productivity with this approach, but there was a lot that left that could have been improved. Most notably, we really wanted to get onto TypeScript. So as the years went by and our code bases became more complex, and we were constantly reevaluating whether it was time to maybe migrate forward and find another approach, two things happened. The first is that the React community started to frown upon higher order components. They're really difficult to understand. It's very the ergonomics of this are not great. And when you look under the hood at what's going on here, it becomes even more confusing. So there was a move towards making these a little bit more explicit and moving them directly into the render method. And that concept was called render prop components. So that happened, and another thing that happened simultaneous to that is that code generation for TypeScript became a little bit more mature. So I'm going to swipe right here and take us over to what that looks like in 2018. You'll see the same component, the shipment details page, but now we have instead of having all the higher order components at the very bottom, they've all been hoisted up into the render method of that component itself. And I think that what you probably just saw is that we're now back in callback hell, right? If you've ever developed for Node before promises were a thing, this should look familiar. You basically have all these little function calls that eventually take a callback that takes a function, that takes a callback, that takes a function, and now we're 8 layers deep before we're doing any useful logic. That's definitely a pain point, although it's not necessarily like a functional problem. This approach did solve a number of different things. The most important thing that it did was it solved the problem around typing. These query and mutation components are much easier to type, and there's a tool that we used called a GraphQL code generator that actually generated them for us. So I'm going to show you that real quick, just because I think it's kind of interesting. This isn't the same, I'll say this isn't the same code generator that the Apollo team released. They released the code generator a little bit after this, and we had already sort of gotten comfortable with this one and the templates and the type formats that it provides. But the one that Apollo provides is just as good, so I'd say you should definitely check that out. But I'll say that what's simple about the code generator is all you have to do is just point it for both of the code generators. You just point it at your schema. You point it at where all of your GraphQL documents are, which is to say every TypeScript file. Check it for fragments, queries, and mutations. And then you say, we want the TypeScript package with React Apollo integration. And what that would do for us is it generates this big file that has all of the different types from our API represented here. What's nice is that that's all type information, so it's going to get compiled out and it won't bloat your ultimate bundle size. But this is really nice because we can start having type safety around the queries and also around the variables that we pass into them. And one of the neat things about it is it solves this problem around checking that the fragment for a given component agrees with what we're using. So what I'm going to do actually is I'm going to comment out rating and save. And you'll see down here that this watcher is going to regenerate the types, and then we get the red squiggly on carrier because rating is no longer on the carrier summary fragment. This was extremely powerful. It enabled us to begin to introduce TypeScript without having to go and model and duplicate a bunch of types in our API. And this was an extremely valuable development. One of the other things that it did for us is that, or that the code generator does for you, is it generates typed components for every operation. So this shipment details component actually has the shipment details query in it. Similarly, this mutation. So now we have all of this inside the render function. The overhead of understanding higher order components is gone. The only bad thing about it is that we have this nasty callback hell, and the component hierarchy remains extra deep. There's also this nuisance around all this common code for managing the edge cases, but we weren't able to improve upon that in that iteration. We can fast forward now, though, because this was in mid-2018. At the end of 2018, in November of last year, the React team announced hooks, which was, they were actually inspired by the migration towards these callback components, or these render prop components. Somebody had built a Babel plugin that would flatten this out for you and do a syntax transform that would turn these into function calls in simple little imperative functions. And the team said, well, we don't really want to use a syntax transform for that. That's not robust enough, but maybe we can figure out a development model that brings forth the same kind of ergonomics. So that's how hooks were born. I'm going to show you now what that component looks like in using hooks. You can see that everything is sort of moved back to the left gutter. We're only one level of indentation. You can also see that instead of having those individual components for each operation, we now just have some simple function calls. And these function calls were generated by the same code generator that we were using earlier, that GraphQL code generator. So they're automatically going to have all the typing information you want. So if I start typing, shipment here, it's going to have carrier, shipper, stops, the fragments that we specified. We have all this nice type safety, and everything's nullable, which is kind of a pain to deal with. But at least, as Danielle said, you're aware of the fact that you need to do that null checking. One of the other nice things about this is that there was another concept that was introduced to React that allowed us to remove some of that boilerplate error handling. Something called error boundaries. The concept of an error boundary is that you can put a component in your visual hierarchy that will catch errors that are thrown, or exceptions that are thrown from any child component, and then perform some kind of behavior, like render an error message. So we took advantage of that as we began to migrate towards hooks. And the way that looks, I'll walk you through how that works. If we look at our app, this might be like where the router would be if we had a router. We added a component here called error boundary that just sort of wraps the page that we're rendering. And inside the error boundary, it's a really simple little feature. There's a little simple static method that you can add that's called getDerivedStateFromError. It basically will catch any error that was thrown by any child component and allow you to set some state. So what we do here is we just take the error, we set some state, and then if we have an error, we render something different. It's really simple, and obviously like what we do in our apps is more sophisticated. We look at the source of the error, we look whether it's transient like a network failure or maybe more like a 500 and render different things. But that enabled us to eliminate one of those conditionals from this list. We don't have to think about error handling in here anymore. And the way that we were able to do that in the query itself is that we overrided the way that the useQuery hook worked. So with hooks, it's a lot easier to extend them and build meta hooks and add some of your own business logic to them. All you really have to do is override the built-in one and then modify the behavior as you see fit and return the same result. So we were just looking for an error from the API, and if we have one, we throw it. It's really, really simple. There's just like one little thing you have to do in the code generator config to say, hey, import my custom use query as opposed to the one from the client library. So what's really nice about this is now we're in a place where all of the bad things that we had identified from 2016 have been addressed. And the only thing that we haven't really been able to address is that the loading state requires a bit of boilerplate. What's interesting about that is that the React team already has something for that, and it's called suspense. It's something that they haven't released quite yet, so I'm not recommending you use it, obviously. And there's a lot of problems with it. I see somebody shaking their head. Haven't released it. It's definitely not robust, but there's something about this development model that is really interesting, and I suspect that we'll have something akin to this at some point this year, or everybody sort of suspects that. We'll see. The idea, though, is that similar to the error boundaries, all we have to do is go to our app and add a different component that says, hey, anything that suspends beneath here should render some fallback UI. The only thing that this is used for right now is actually for lazy component loading, but you could see how it might be usable for fetching the data for a given page. And what I'm doing here is importing that and rendering a loading indicator if we're suspended. So the final shape of this component ultimately looks like this, where we have a couple of operations here from Apollo. We're able to thread our props directly in using just some imperative function invocations. There's no crazy composition of higher order components. There's no really deeply nested hierarchy of components here. This all reads very nicely. And what's nice about that is it means that the framework's getting more and more out of our way as we progress. There's less care and feeding of the framework involved, and developers with this level of clarity can focus more on the business logic that is the essence of what we're trying to build. I'm going to go back to my slide deck here and just say that we don't know what else is coming in the future, maybe suspense, right? But what this is showing, hopefully, is that there's been a clear and consistent drumbeat of innovation on the front end both around ergonomics and just like making it easier to write the code, as well as around making it less error prone to write client code that attaches to a GraphQL API. Convoy continues to want to, we continue to try to innovate ourselves. We've built certain things for a GraphQL, like our own client cache, and we do have some additional little bits of tooling here and there, but I'll say that every time we build something ourselves, the Apollo team comes around and builds something even better like 6 months later. So it's been a really good ecosystem to be a member of, and I think that's sort of all I have for you today.